Yeah, works for me too.
No, that's not me coffee. Okay, wait, it's probably I'm off.
I can't hear anyone on the stream.
Okay. On your OBS, you might have to add desktop audio separately.
Yeah, like whenever you spoke, I couldn't hear anything. I can't hear anyone on the stream. Oh wait, I can now. It's like a solid 10-15 second lag. But
It's fine. Hello? Can you? Is it echoing?
Can you say something again?
Okay. Is it echoing?
A little bit, but I guess it's fine.
Kind of weird because I'm presenting my screen and for some reason there's like that mic voila green thing there also.
Shit. No, but like it's not that bad, honestly. Like I can barely notice it.
It's fine. Yeah.
I think we can get started.
Okay. So, so, hi everyone. I am Kunal, and we're going to be talking about Docker today. What is it? Why is it? Why would you use it? What's up with the whale? All the general questions that you might have. I'm not an expert here. I've been using it for what, a month now. I'm just here to talk about something I find cool. And if you see me make any mistakes, you can feel free to stop me and correct me, and won't be hurting my feelings in any way. You can stop me and ask me questions if you want, as long as it's not too hard. Right, for this week, we have a mascot. So I didn't want to stomp on the tradition that we had every week. This is Molly. I found this happy little picture of Molly chilling with Tux, the penguin, and uh, Perry, gopher from Golang. I don't know what creature it is. You know, Molly's a whale, and so the actual Docker mascot is called Moby Doc. This is Molly Doc. She was actually a whale adopted by the Docker project. You know, how many organizations have a pet whale? And this is the last time you're going to be seeing her throughout the presentation because I was lazy to copy the same image over and over again. Might meet her during the hands-on though. Now, what is a container? Let's say you build chairs. Okay, you have wood, you have nails, and you have a hammer. You have a saw, you have polish, and you have everything that's required to build a chair. And you do it as a leisure activity because why does anyone do anything for leisure? Now, your friend, he wants a chair, but he's building one out of necessity. He doesn't want to buy all the tools that are necessary to build a chair. So, what is he going to do? He's going to come to your house, he's going to get a box, he's going to take some wood, he's going to take some polish. He's gonna take some tools and he's gonna take that box and he's gonna that box container has everything that he would need to build the chair, right? Now that's what a container does. This you're packaging an application along with everything that it's dependent on and using it whenever you need it, right? Now, how many of you have used C?
Have used what?
C language, C. Okay. So C has some libraries that you could see, stdio, something that has all your printf, scanf, and would it be safe to assume that more than one there's more than one app that uses all these things, all these functions? Anything that you build with C might need a print statement, right? So if you package every application with your standard, all those print functions, then each application would be a lot bigger in size because that single stdio library is huge, correct? So that is what you call a dependency. Now, how would you handle it? In most systems, there's something called a shared library. Now it's like, say there's a location in your system, and if your program needs that, it has a reference in that system. Okay, for Linux is something, for Windows it's going to be something. You're going to say, okay, hey, you can get this function from here. Okay. Uh, Now, what's going to happen when you want to use it use the same program on different systems, right? Let's say you have two programs. One is written in Java and another is written in C. So for those of you who have not used Java, I have not used Java myself, but I'm sort of familiar with the how it goes. When you compile a Java program, it forms a .jar file. Okay, so this jar file you can take it anywhere and run it on anything as long as it has that Java runtime. Okay, so it doesn't matter whether you're on Windows or Linux or Mac OS, anything. You just take that one compile program. Doesn't matter where you compile it or how you compile it, it's going to run. But in the case of C, if you compile it on Linux, you will be stuck. You can't exactly use it on Windows. You'll need to compile it again with those Windows dependencies. Now that Java application, it would be like a crude example for a container because it comes packaged with all the dependencies. Now I say crude example because I'm not exactly sure how it works. So, correct me if I'm wrong. Uh, right, where would you use Docker? Because you know, uh, Docker takes the same concept that you have of um, containers and it amplifies it. Okay, there's no limits. You can use Docker to run applications and systems that have nothing else on them, no tools, nothing, just that Docker one app. Okay, so you can use Docker to create build systems. You want to, if you have like multiple tools that you need to compile an application, which is possible. Okay, say your application relies on Java and C. So if you need to compile it, you'll have multiple tools, and you don't want to install all of them. You can create a container with those tools and use that single container to uh, as your developer, right? And you could even have a nice little virtual network between different containers themselves. Okay, sort of like building blocks. So it's basically what it does is it packages all the tools that you need in order to build your chair, and it puts them in a box. That's what Docker does, but instead of your saw or your wood or whatever it is, it compilers. Now it's an easy, clean way to ship your applications as well. Uh, let's say you're building an application for a company, okay, and it's a Node application, and Node has like tons of versions, and it's very confusing to keep track of. In fact, the version that comes with Ubuntu is like 10 dot something unless you change, but the current version is 16. So let's say you developed an application for Node 16, okay, that version, but your whoever your client is, they have Ubuntu with Node 10. Obviously, they're going to have issues trying to run it. So might as well not deal with that and compile everything together and send it to them so they don't have to deal with anything but for installing Docker and running their container. Okay? Uh, how does Docker run? Docker has it's called uh, Docker uses something called a Docker engine. Okay, it's think of it as a single virtual machine of sorts that lies on top of your system, and that single virtual machine can handle all of your containers, sort of a daemon process. Okay, wait, is the audio getting messed up? Okay,
It's
I
fine. It's
was
fine.
getting messages. Okay, cool. Uh, was I? Now, Docker on the backend relies on something called the Docker engine, or you can also call it the Docker daemon. What is a daemon? It's just a service of sorts. Okay, it's something that keeps running, and you're asking it for something, you're getting something. Basically, how the internet works, right? You have a server computer somewhere, and your computer is asking something from that server, and the server returns. And the fun part about this Docker daemon is that it uses this exact same REST API calls. So any changes that you'd like to make, if you want to make your own Docker client instead of using the Docker command, if you want to make your own GUI client, you could do that as well because it's just your regular get, post, all of those REST API calls if you're familiar with them. Okay. Uh, so there's two things you want to know about Docker. Okay, there's two main things. So there's an image and there's a container. An image is sort of like a blueprint, and these images are placed in registries. What is a registry? Can be something like, you know, how you store your code on GitHub. You store images on the registry. Okay, so all of these are completely compiled images. All of them go in a registry, and you can pull those registries. And once you pull them and run them, then they're called containers. Okay. So I'm going to do a little bit of hands-on because I believe that is the best way to uh, learn about Docker, right? So share my screen. So how do you pull an image from your registry? So your registry would be called Docker Hub. Okay? Docker Hub is where all of your official sort of images are, and this is where you're going to find all of your Ubuntu and Node, MongoDB, all everything that you. Okay. So let's say you want to create a container for Arch Linux. I'm only using Arch Linux because I already have Ubuntu. I want to show you the difference between. Right. So to pull an image from the registry, it's going to do Docker pull. Let's check out Ubuntu. Okay. Let's check out Linux because I really want to show you the different things running on the same system. Yeah. Okay. Docker pull Arch. Okay. Simple command. What it's going to do, it's going to download the latest, and there's different tags here. Okay, you can download the latest, or the other tag is called base development, which might be the development version. In Ubuntu you might find 20.04, 18.04, and all of those. Yep. So what we're going to do here is pull the. Why is it taking so long? I thought I already pulled it. Okay. Right. So now if I type Docker images ls, it's going to list all the images that I have downloaded. So I have the repository, which is called Arch Linux, you can see, and the tag should be the version that you downloaded. You have an image ID. So and you have the other information created when was your repository created, what's the size of the repository, right? Now if I say I want to create an image, just want to do, if you want to create a container, sorry, you docker create, and it's going to create a container with a randomly generated name. Now if I do container ls, sorry, ls a, it's going to show me all the information about the container and the initial command. So this is what runs when you run your container. It'll be different for when I run a node application, which I'll show you later. Name. Now you want to run it, so you want to run your intelligent hardware container. See, docker start, and you want to type -i. What does -i do? Interactive mode. So basically, you'll be able to interact with your container. That's it. Okay. That's what that flag does. And you can also use this container ID if you don't want to type out the entire thing. Nothing. Skip the start command, and instead I'm just gonna run Linux directly, and that's not interactive mode. What is wrong with it? Yeah. Okay, thank God. Never mind. Not sure what went wrong there. Supposed to have the start command. Anyways, uh, what does Docker run do? It's going to do all of it automatically. So we created an image and we pulled an image and then we created a container. Docker run, it just runs both of those commands together. Okay. Now you're inside your container now. Now if I do uh, and install NeoFetch, you see that that's two different operating systems running on the same. I'm using Windows subsystem, so it's running on the same kernel. It's a completely different operating system. This is the Windows, and this is the Arch. All right. So you can use this as a normal developer environment. You can install all of your tools. Install install all of it. I won't be doing that because it's 200 MB. When you want to exit, just type exit and it will be out. Okay. Now, if I wanted to remove a container, Docker PES is a command that will show you all of the containers that are running or were running, right? And it gives you the names MB, container ID, all of the commands. It gives you all of the information that you need. If you want to remove a container, all you have to do is docker rm. Docker rm, and it removes that container. If you want to delete an image from your system, you clear up some space, the image ls, and copy this docker rmi. Yes, I'm going to force it because there's still other containers that are using this image, right? So we're going to force it to get deleted, and it has deleted the image, right? Now, what I want to do is try to package an application and run it on a system that has none of the tools installed. Okay, I'm going to be using uh, I'm going to be using Node, and we're going to be creating something called a Docker file. We're going to be building an image and pushing it to the repository, right? So before I do that, I'm going to create a new repository here. So that way I can pull it into my VM later. Okay. Public repository. And hello, right? Now here, and yes, okay. VS Code session. So we're going to make a simple Express.js app, and we're going to make a Docker file to create, to turn it into an image, all right? I do that to install Express. Yeah, it's going to be a simple and simple web app that's just going to sign, right? That's it. Make sure it needs to be working. So I'm going to be creating something called a Docker file. It's just a file called Docker file with a capital D. It's going to be readable to the Docker application when you build it, right? So your first line is going to be, okay, you're creating an image. From what image do you want to create? You're creating a container. From what image do you want to create it? Okay. I want to create a node image. So I'm going to look up node. Okay. And if you can see, there's like tons of different versions, right? and I'm gonna select node, whatever the latest one is. So if I put node latest, it should work. From, so from node, and you notice these, all of them have a different name. Alpine, Buster, Buster Slim, Stretch Slim. All of these are distribution names. Buster and Stretch are different Debian distributions, like not distributions, release cycles mostly. So they're different versions of Debian. Alpine is a different distribution altogether. So you get that flexibility, right? So I don't see a latest here, latest tag over here. So I'm not going to take any chances. We've already had one failure today. I'm going to say Node 16 Alpine dot type. And if you have the Docker, uh, what's it called, extension installed for VS Code, it's going to give you all the options here. The stamp piece. So first thing it's going to do from node 16 Alpine. So it's going to download this image node, right? Second thing you want to do is you want to set a working directory in your inside your container. Okay, so it downloads. What this does is it downloads an image, and as you saw, it's a proper Linux distribution, right? As I showed you before with Arch Linux, it is a proper Linux distribution. So you want to create an area in that place where you can set up all your files and where you can run your application from. Now, obviously, you don't want to run it from your root because that's not a good idea. It's giving a lot of permissions. Okay, anyway, work directory. So what this does, it's like the cd command. Okay, you'll cd to that working directory, and all of the commands that you type after this will be run in that directory. So I'm gonna do slash home slash. So it's gonna create a slash app folder in the slash home folder of here of the node image. Next thing you want to do is copy. Okay, one more thing. There's one more file you want to know about called .docker. I've ever used Git before. There's a git ignore file, which is there purely to ignore stuff that you don't want to include in your repository. Right? So the same thing here. I don't want to include node modules because it is, well, huge. Anyways, node modules. We ignore that file. Over here, what I'm going to do is I'm going to copy package.json. Just package.json. We're going to copy both of these files. Package dot. So this is it's going to copy package and package log.json. This is a wildcard which is going to include everything that starts with package and ends with .json. So it's going to copy both of these files and it's going to copy them to the work directory, right? Whatever we said, slash home slash app, it's going to copy them to that directory. Next thing you want to do is you want to run npm install. So that's a normal command that you use to install all of these node modules, and you want to install that in your and you want to run that command in your container as well because you need those dependencies, right? And last thing you want to do is copy the rest of the files. So we haven't copied index.js yet. Why am I doing this? Because whenever Docker builds a file, it's done in a layered fashion. Okay. Whenever Docker builds an image, it's done in a layered fashion. First, it's going to copy, then it's going to run npm install, then it's going to copy all the other files. Here's the thing: npm install. How often are you going to change the dependencies in your project, right? So you don't want to install these. You don't want to run these commands all the time because they take up time and you don't want to waste time. So what you're going to do is you're going to copy the rest of the files after you have all your dependencies installed. So next would be copying all of the files from your source to your destination, right? See, it gives you a handy little hint over here. The first variable, the first argument is always the source, and the last one is always your destination. And I'm pretty sure you can copy multiple files individually as well, as long as the last file is here. As long as the last argument is your destination. Okay. Now the next thing you want to do is you want to create a command. So what does this do? Now you created your Docker application. When you run your image, you want it to run your application as well, right? So what this command does is includes that includes the command that you need to do to run your application. If you've noticed, I have two different kinds of commands over here. One of them is called run, and another one is CMD, and both of them, they look like they're doing the same thing, but here you have an array. Why is it different? This run command is something that runs when you're building your application. When you're building, it runs all the. You don't want to run your, and this only runs when you're running the container. Okay, you don't want to run this command when you're building your container because it makes no sense. It's just going to get stuck. It's going to start a server while it's building, and you don't want that. What CMD does is, if you noticed there, okay, yes. Oh yeah, I deleted it. Great. Okay, let that install, and we'll talk about it later. Here you have your, we have our program. Here is our Docker file. Okay, I'm going to go over it again. From command, it's going to download the main image that you're building off of. You can also, you don't want to do this. If you want a full, Ubuntu installation, you can do that as well. Another thing you're going to have to do is sudo apt install Node.js, right? But if you don't want to individually download everything, you can just directly use the Node image that is already available to us. Let's not spend more time downloading something than we need to, right? Is that done here? Yeah. Docker image ls and Docker run. You see the command here? That's what this does. Okay, that's what this. What do I call it? I can't call it. That's what this instruction does. It sets the default command that runs when you start your container. Okay. Okay. There's a question. When you install more dependencies, they install within the container. Whatever dependencies you want, you can mention in your Docker file and give pip install. As I said, if you want another dependency, you could do pip install. As I was here, I gave the example of Ubuntu and installing Node individually instead of using the Node package directly. What are you doing there? You're just creating an image and installing Node as a dependency there. Okay, and it's the same thing here with npm install as well, as Madhav said, where you're installing the dependencies manually after when you're building your container. Correct. Save this, and I'm going to pray that it works here. And Docker, really correct? Yeah, Docker will. Now, what, now you need a tag name. So you do that with -p. What is a tag name? Your repository along with your you want to name your image, right? So the tag name allows you to do that. So you include your repository as we did over here. What did I name it? My profile. Where is my repository? There. I named it slash hello world. So that is going to be my repository. I'm going to do that there. Hello world. And next thing I'm going to do is include a tag. Tag. I can name it anything I want here. So if I name it hello world colon colon, if you notice, we use the colon here as well. Let's just separate the repository name from the tag number or tag ID or whatever. I'm gonna just call it test for now. And you need the location of the Docker file. So you can call Docker file, or since you're in the same folder, I'm just gonna go dot slash. Okay. Now it's gonna take a while to build, and while that happens, I'm gonna go and see if I missed any questions. What terminal is that? Yeah, it's WSL. I had a very sad moment this week when I had to install Windows again. WSL is nice though. I like the terminal. It has all those fancy effects that you get in KDE as well. The acrylic. See acrylic. I want to see acrylic. Oh yeah, let's use. It's got those retro term effects as well. Very cool. But I don't think any of you can read it. Can you read it? Yeah, I'm gonna go back to not really. Probably not with Himalayas either. Anyways, back to this. Oh god, I just realized, is my font too small? The font is readable, right? Okay, a little bigger. Font size 15. Okay, oh, that's too. Okay, now the build is complete. If you saw that, build is complete, and what we have now, Docker image ls, gonna have the image that I built, correct? It's got here, got my repository, it has my tag name, it has its own image ID. Now what I'm going to do is run the application. How do I do that? Just say docker run, and you need to mention the name as well. Otherwise, I think by default it uses latest, but since we haven't named it latest, it's just going to try to pull it from the repository, and there's nothing in the repository. We don't want to deal with that. I run that. Okay, it says server running, right? Now here's the thing. Your container isn't going to work. we served it on port 8080, but if I go to localhost 8080, so that's how you access your web applications when you're developing them, right? If I do localhost 8080, it's not going to do anything. So now you need to. This is because the port. Your port is basically a connection between the computer and the outside world, the internet, right? That port in the container isn't connected to anything. You're gonna have to change that, obviously. So since we set it to 8 port 8080 in our program, in our web application here, go back to Docker file and we're gonna expose 8080. So this will be now that this port is exposed, it can be seen by Docker, okay, and not by a computer yet. For that, there's one more step. Okay, since you changed the Docker file, you're gonna have to run the build again, and I'm not gonna cancel. Okay. Uh, Let me just stop this. Oh yeah, that's one more thing you can do. If you want to stop a container that's running, just do Docker stop and the container ID. Very simple. Right. Uh, Now we're going to build it again because we made changes. We exposed the port. We changed the Docker file, so you're going to have to build it again. Docker build and the tag name. It can be the same tag name. It's just going to update the same uh, thing in there. Yeah, it is fun to say. Okay, so it's built now. I'm going to check my images again and make sure that image ID created 19 seconds ago. And this, what remains is just the shell of the older image. Since we updated this, but there's still a container associated with the older version of this image, right? So it just stores the ghost of that image and you can delete it later when you delete the container. Okay? So now that you have a new container, what you want to do is your container have an expose port. Now you want to Docker run. Okay, this is going to allow you to connect that port with your actual system. So let's say you want to use the same port in your system, 8080, okay? And you want to connect it to, actually no, I'm going to use 5000 just so you don't get confused because the first number is going to be the port on your system and the second number is going to be uh, the port that you exposed on in Docker, correct? In the Docker file. Okay? And I'm going to do the same thing again. We have the world and test. Now it should run the server, and when we go to localhost 5000, there you go. You have a working web application running out of container. Now, what we're going to do is, oh my god, why doesn't Control C work in any of these? We're going to push slash hello. Now, what push is going to do is you have a repository in your Docker Hub, and you have something with the same name in your something with the same name in your local images, right? When you push it, okay, one more thing, I've already logged into this. Okay, you can just log in with Docker login. Otherwise, it's gonna ask you to log in again. Now, when I do Docker push, it's gonna push it to this repository, and I'm gonna hope that it uploads just fine. Uh, yeah, I have no idea why Control C doesn't work on this terminal. Yeah, it's very weird. I don't like Windows. Anyway, yeah, okay. So I believe it should be pushed, and there you go. You have a test tag name here, and that has your latest image file, and it has all of your commands as well, right? Now, I'm gonna bring in my VM that has nothing installed on it. Right. So it has no node, it has no npm, nothing. And all it has is Docker. Okay. And on Linux, for some reason, it needs complete root access. So whenever if you're trying it out on Linux, you're gonna have to use sudo docker and pull it slash uh, the name hello world, yeah, and tag name test. Okay, it's gonna pull the same repository. Now this has none of the tools installed. Okay, other than Docker, it has nothing installed. I don't even think it has GCC. Okay, it does have GCC. Maybe it just comes with GCC. There you go. I did good. Now if I do Docker image s, it has my application right here. I'm gonna Docker run. I'm gonna run it in a detached state this time. What is the detached state? It's now gonna give you the output. Okay, it's just gonna run it in the background. Docker run d slash hello world latest. There's one more thing like we're forgetting here. That would be the port. Obviously, we need to, you know, extend the port here as well. So I'm going to extend the port 6000 maybe, and obviously the same port because we hard coded it in our application 8080. That state and no permission because you have to use sudo. There you go. Unable to find image because I used the wrong tag name. Test, not latest. And it's done. It's created. And it's running in a detached state. So if I do sudo docker ps, it's going to show me that it's running, and it's going to show me the port that has been forwarded on my system, right? So if I open, say, a Firefox session here, and oh my god, this VM is so slow. And if I access localhost 6000, because that's the port that we set it to, it's restricted for everything other than browsing. Oh wow, Firefox is just out here protecting me, I suppose. I don't know. Okay. Anyways, we're gonna do something else. We're gonna use port 80 because that's the HTTP port. That way I don't have to deal with Firefox settings. Okay, and that should work. Port 80. There you go. Hello world, and it's working without npm, without node, without any of it installed. If you want to access your detached, what I meant by detached is, so yeah, when you run it with hyphen d, it's a detached container, right? If you want to access it again, you just need the ID of your docker, please. Sudo docker, please. Damn it. There you go. You just need the ID of your container and one docker attach sudo docker attach and there. And it's not going to show me anything because the only thing we're printing is server starting on this port. So if there's errors, however, it's going to show me. For example, if I try to access localhost slash 123, cannot get 123, and it didn't show me an error. Huh, I'm not sure why it didn't show me an error. It should. You can try it out yourself. Now, best way to, and it's not closing here also. What is wrong with control C? Now, the best way to learn Docker is,
It'll take some time to close the container. So like
ah,
it has to do some. So
okay, yeah,
internally it'll like tear apart everything. So it might take some time. If you want,
yeah,
just do a Docker kill.
that makes sense. Okay, uh, so the best way to learn Docker would just be to use the getting started container. Okay, just do Docker run Docker slash getting started, and it's going to take you through a whole tour with everything that you need to know, including Docker Compose, Docker Volumes. Docker Volumes is important because, as you can see, once I update a container or if I, delete a container, none of that data is saved, right? So Docker Volume allows you to have some form of persistent data that way you don't lose it. And Docker Compose is something that, I say this, if you have a lot of a lot of containers that work together to form, you know, a working application, maybe a cloud microservices, for example, that then you would want to use Docker Compose. It allows you to manage a lot of containers at the same time. And I think that's about it. I don't have anything else to show off today. And I don't think I strictly followed the non-technical term, but the non-technical, you know, condition. Uh, is there, are there any questions?
I think there was one question a little above by Utkarsh.
Oh yeah, yeah. That I answered. You also answered that. But
No, no, no. So like right after that. So
when a
like
container is running, yeah, you can do that when a container is running,
hmm,
as in normal. How would you use a normal Linux terminal? You need to start a new. You need to execute a new bash. So okay, how do I explain this? You have a terminal running. I'm going to create another software run. Okay, why do I have one? Uh, let's check the-
My question basically was just that, say, suppose you're running Arch Linux and then
yeah,
then you attempted to install GCC.
yeah.
So, say you stop the container.
Hmm.
Uh, is the container modified, or is that
If you, yeah, it is modified,
it's
but it's
modified
not persistent. So if you need to update a container, right, you
volumes?
can't exactly update it. You'll need to replace it.
Okay.
Okay. So you lose that data. But if you want, that's what I was talking about Docker volumes.
Yeah.
Docker volume will allow you to have some form of persistence. Generally, you don't use it. If you want GCC and all, you include it in your Docker file only.
Right. No, I'm saying suppose if you're getting the Docker file from, if you're say pulling it from someplace else, if it's not your
Huh.
own thing,
If you're pulling
then
it,
yeah. Say if
you
you're pulling
can
the
create a Docker file. See, one second, let me show you something. Uh, I can just create a Docker file with anything. Okay, you're pulling a Docker file from somewhere. You don't need to have like an application. A Docker file is just there. It creates an image. You don't have to copy any source files to it. Um,
I wait, like I don't think that's what you meant. So like, Utkarsh, just go
yeah.
ahead, finish your question.
Yeah, see, what I meant was, say,
mhm.
like, you're not the person who made the Arch Linux Docker file, right?
Yeah.
Like the image. So, say you're getting it from some other source,
Hmm.
and then you're installing dependencies that you need on top of that.
Hmm.
Okay, so you
Is
said
it?
that volumes helps with some persistence. Or does that again? Does that replicate or does that update the same container?
Think of a volume as sort of an external storage key. It's like pen drive. So you can use it with basically all of your containers. Hmm? You just how do I? Where is he? Okay, there you go. Now Docker volume create. Let's say my volume Docker volume inspect. If I wanted to start, let's say a Docker container with this volume, all I have to do is plug it into the Docker run command. Okay, Docker run. Uh, same thing again. And v my volume. So the name would be my volume, and what folder you'd like to save in. So slash maybe slash user slash bin. I believe that's where most of your applications are. User install applications are installed. So basically, like a pen drive. Okay, you say, okay, I have here, I have a volume. I'm connecting it to slash users bin. So anything that gets saved in slash users slash bin, that will be saved forever. Okay, we'll see if it works. I hope it works. Okay, uh, well, I can't see it here. ls slash bad idea. I should have done something else. Uh, slash slash home slash data. Now I'm creating a completely new. Whenever I run Docker run, correct, it creates a new container. Okay, So this is a completely new container that I'm creating right now. I say hack cd slash ls data. Let's see. And we'll say, okay, I'm going to be very honest, I've never tried this before. I've only used it for like a database that was there long ago in the getting started guide. Hoping this works. Right. That's at least we have one. Okay. So now I'm gonna exit this container. I do docker PSA. This container was called Goofy Herschel or something. Now I'm going to create a new container using Docker run again. Okay, and I'm mounting it to the same place. What I'm hoping is going to happen is that I'm going to be able to see that same text file that I just created in that other container. Okay, so data, why is it cat test dot break? Uh, Once again, have a slash home slash data. Yes. Already exists. Okay, so the volume worked, but for some reason it's not letting me uh, see what's in data. Oh, you know what this is? Uh, in the first container when I used slash user slash bin instead of slash home slash data. So this is all of those binary files from slash user slash bin. That okay, so the volume works. I just didn't execute it very well. Does that answer your question, Utkarsh? Docker volume.
Yep, thanks.
Let me see if there's any other questions. Why don't you have user mode containers? Oh, okay. That's the yeah. Sudo did make me nervous as well. I feel like it's a little better uh, Windows because I don't have to use sudo. Yeah, check everything.
There's like another thing that you can do. So,
Mhm.
for example, so like as Utkar said, let's say you have like an Arch Linux image and you install
Mm,
some stuff in it. Let's
mm,
say like you install I don't know like Grover, like because why not? And after that, when you stop the container, it's going to die away. So one
yeah.
thing you can do is you can either persist it to some form of volume,
Mm,
or if you made some changes to your files that you want to create another image from. So obviously you can't create another Arch Linux image because that's sort of fixed or like immutable.
right.
That's the right word.
Right. Right.
So there's another command that you can use. It's called docker commit.
Mm,
That would take the current container's file system. So basically, an image is nothing but a file system arranged weirdly. There's like it's pretty
huh,
cool.
I
So
know.
if you
I
guys
know.
want to go check it out,
With ch root and all,
but
it's very interesting.
yeah, so like it would take the current container's file system and make a new image out of it
Mm,
that you can again like if you want you can push it to Docker Hub or you can play around in other ways
mm,
whatever you see fit. So
yeah.
yeah, Docker commit is like another thing you can try out.
Yeah. So, would it be safe to say that it's if you created a Docker file with the same image and then you ran all of those commands, Uh, will be the same thing, like what Docker commit is doing.
Sorry, what?
Like if you created a Docker file and ran the same commands that you would on your
Hmm.
in your container,
Right.
and you say git run apt install gcc and all that stuff, would it
Hmm.
be the same thing? Uh, wait, how do I frame this? Okay, does Docker commit create another Docker file from the changes that you've made?
I'm not sure if it creates a Docker file, but it creates another image. So like as Anirudh
Hmm,
mentioned, it takes a snapshot of your file system
hmm,
and that image. So an image is basically one big tarball.
yeah.
Uh, if you want, you can extract it out and like you can see it's like a proper file system.
Huh,
So if you take like the Ubuntu container and like you take the you extract out the file system,
yeah,
it'll basically look like how your laptop is right now. So like you'll
yeah.
have a slash, then you'll have user bin sys proc.
Hmm.
You won't have proc, but you get like the general idea.
Is anyone here familiar with chroot?
I haven't really used it personally, but like I think I know what it does as like
Yeah,
a
ba-
construct.
yeah. Basically, say this is your Linux system, right? You have all of your this is the root of your Linux system. Okay, you have all of these folders. Now, as Madhu was saying, when you extract an image saying you want to say, for example, you want to do something, you will see the exact same folders. Now, chroot is kind of an old command that allows you to change the root folder of your Linux system. Okay, basically, say right now, if you run a container, what it's going to do is going to change the root of your Linux system, and it uses the same kernel. So if you saw right now, my entire thing is a mess. But if you saw what I did before, that was kind of what I was trying to show, but I didn't want to go too deep into it. I'm pretty sure I ended up confusing you guys a lot with that. But when I did the neo fetch for both of those systems, uh, it had the same kernel, but the operating system was different, which means it was basically all of these folders. It had changed the root folder of your Linux kernel, whatever it was executing. Okay, that's basically what it does. And I think I've used it a couple of times. You use it when you're installing Arch Linux, and you can use it on if any of you have used Termux on your phone. You can use it there as well. It's a very handy tool, sort of like a container, I suppose, your own container. Anyways, I think I am done for today. So if anybody else has anything to talk about, I think you guys can.
Also, like I just for whoever is on this call, I just want to like make it really like abundantly clear that Docker is not equal to containers. Docker enables
Yeah,
containers,
yeah,
and
right.
containers are something that have been there for
Yeah,
I'm not even sure how
I
long.
think
So like
I mentioned it somewhere here also.
yeah, and
Uses this concept, that's all. It's
yeah,
not,
it's really simple to write your own like 50 lines of code,
you can make it.
be it in Bash or Python or Go or whatever is your language of choice, and you
Mm,
can write your own container, which is pretty stable and pretty. It's more or less similar to how these things do it. The only difference is that Docker just makes it really user friendly for people to write containers, especially with like Docker files existing. So Docker files was like the biggest selling point of Docker as like a company. and that sort of led to the adoption of these technologies because it was easier for people to um, ship different applications in terms of whatever dependencies were there and whatever binaries they were running. So if you just write like a Docker file, as Kunal showed, and you just push it to Docker Hub, anyone can like pull it from Docker Hub and use it, and it would work out of the box without any issues. So uh, it's really really nice, simple to like write your own containers also. And there's a lot that's going on behind the scenes that like is really really cool to know about. If some of you are interested, I can post a few links on Slack after this. So uh, containers are made up of like I'll just mention it. I won't go into details because like if I start talking, then it's just a rabbit hole from there. So like there are these two things. If you guys want to check
No,
look
I'm
it up.
completely done. You can start talking. Yes.
No, it's fine. We are anyway out of time. So there are these two things. If you guys want to check it out, it's called C groups and namespaces. If you guys want to like check out how containers do what they do, those are the places to start. And if you are interested of like learning in depth what's going on behind the scenes, just put a message on Slack and I'll spam you with links.
And I think if you do the getting started guide on Docker, there is a link to a complete video on this as well, on namespaces and C groups and how to build your own container with Go.
Yeah, that video is like super popular and it's like really, really good in terms of the way they do it and explain it. Like I would recommend any talks by that person. So her name is Liz Rice. Uh, just, I would highly recommend anything by any talk by her. Yeah, so as Anirudh said, okay, so there a little bit of background in containers. The people who are like who've been working on container technology and like the core of containerization for a long time, they too have differing opinions on um, some of the terminologies that exist around containers. So to standardize different container providers, I'm not sure providers is probably not like the right word, but to like standardize the way containers are built and run, and some of these images are built and like shipped. There was like a committee type of thing that was formed called OCI, that stands for Open Container Initiative, and OCI provided like a specification for what an image should look like, what um, containers, how they should be like what interfaces should be provided for them to be run, and so on. So interface is like this common thing that you can rely on for it to not change, but like the implementation of that can be different. So there are different providers. So there is Docker, which which has like Docker files and all of that. But internally, Docker files and like what it would do internally is it would follow OCI image specifications and runtime specifications. And the way it does that is, so if you dive a little bit deeper into Docker, whenever you type something like Docker run, that sends a request to the Docker daemon, like Kunal said, and Docker daemon communicates with something called container D, which is a little bit low level than Docker, so it doesn't provide as much abstraction and is not as easy to use. But now it is as easy to use and it's really powerful. And container D talks to this thing, the lowest of the lowest runtimes called run C, which is meant, which literally stands for run containers, and that uses all of these OCI specifications. It's like end-to-end compliant. So like if you use this thing called Podman, which Anirudh mentioned, that also is OCI compliant. there is this thing called Builda, which you can use to build container images that also is OCI compliant. So like to understand the core of containers and like what's happening, um, if people are interested, you should really look into stuff like OCI runtime, OCI specification, C groups and namespaces and things like that. I have a few good resources, so like if anyone's interested, just ping on Slack, hash general or whatever, and I'll send them over. It's not an issue.
So much to this. It's so interesting.
I'm not sure if it's C run.
It's
The only
run
thing I
C.
know of is run C.
It's run C. It's run C. I,
Yeah, so if something replace something, then run C probably replace C run because that's the only thing I've heard of
Docker,
and seen.
before being directly dependent on run C, I think they used to use LXC, Linux containers, which are still there. And again, it adds to Madhav's point that Docker doesn't mean container. This method to harness the power of containers.
Yeah, and like the reason that I mentioned Docker doesn't mean containers is because there was like a pretty big outrage that happened a few months back because of how popular Docker is in the container world and like how common it is. Like basically everyone uses Docker uh, for their container solutions, right? So because of how popular it is, Docker somewhat became synonymous with containers. So a few months back, Kubernetes, if you guys don't know what that is, it's totally cool. So Kubernetes is this, you can think of it as like this tool to manage containers. Uh, a while back, it used to run only using Docker. So the way it was described was it was a Docker container management system or like an orchestrator type of thing for Docker containers. But turned out that Docker is just like extremely heavy, or like it's just a huge thick piece of software, a lot of which features aren't even used by Kubernetes. So Kubernetes decided to deprecate Docker, uh, and that was called the Docker shim deprecation. So if anyone wants to like check out that blog post or whatever, so it was called the Docker shim deprecation. And when that notice came out, it wasn't really too much of a big deal because containers were still there. Everything was as it is. Kubernetes would still run okay. There would be a few breaking changes, but none that would be serious enough to cause a lot of issues. They were very much fixable. But because Docker was so popular and synonymous with containers, everyone just lost their minds. There was like this huge outrage in terms of containers being deprecated in Kubernetes. Like, what's going to happen? What is this? We've been using this. How can you do this to us? This went on and on and on. And then there was like a lot of effort. So in Kubernetes, there are like dedicated teams for marketing and handling such fires that come up and outbursts that happen. So after a lot of efforts and like a lot of blog posts explaining what's happening, what is what, all of that, people sort of understood that okay, containers are not equal to Docker, or like Docker isn't is Docker equal does not equal containers. Our systems will still run okay, uh, and probably run faster because of this improvement. But so Kubernetes also provided what exactly would break if they have it, and what to do to fix it also. So like after so much effort and so much outrage, uh, people sort of calmed down and understood what was going on. So that's why I wanted to like make it very clear, like for at least people on this call, that Docker is just one enabler of container technology. I think we can like go off stream and just like chill for a while.